I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, I will discuss about spatial and gray level resolution, zooming and shrinking of digital images. And in the topics, what we are going to discuss in this session are: one is what is spatial resolution and what is gray level resolution, and what is the purpose of applying different concepts like zooming and shrinking of digital images, and what are the procedures that we can apply in order to zoom and shrink digital images. And we will also see one example applying different methods and how to zoom the image. So going to the detailed discussion. So before going to the actual topic, one important concept we have to recall, that is representation of digital images. So here an image is defined as a two-dimensional function. So it can be represented as f of x comma y. So in this, here x and y are called the spatial coordinates, and whereas here f is called the intensity level, or the f can also be called as gray level. Now, so in order to concentrate on the spatial resolution and gray level resolution, in order to do spatial resolution, we have to concentrate on this two coordinates x and y. In order to perform gray level resolution, we have to concentrate on one value, that is f, intensity value. So here, if the values of x, y and f are all finite and discrete quantities, then that particular image is called as digital image. Now, so as we are discussing about the spatial coordinates and also the value of f, we need to also understand, that is already we have discussed this in the previous lectures, and we have to recall this concept. So here, image can be represented in the form of a matrix. Here generally it is represented as f of x comma y. So here x and y are the spatial coordinates. So here we can observe these are all the values of x and all these are the values of y. Here x and y values should be positive numbers. So x value will be varying from 0 to m minus 1 and y value will be varying from 0 to n minus 1. So image can be represented in the form of m by n. So where m represents the number of rows and n represents the number of columns. So here, if you consider, this is one pixel value having the coordinates 0, 0, x and y. And here, if you observe, this is another pixel having the values like 0, 1. And if you consider, for example, this pixel, the value, the coordinates at this particular point will be 3, 0. So where here 3 represents the value of x and 0 represents the value of y. So here, these will be the values of one particular pixel. And the same can be represented in the form of a matrix. So this is the matrix. And so the size of the matrix will be m by n. So where m represents the number of rows and n represents the number of columns. So here which will be representing the value of x and the value of y. So here you can observe here f of 0, 0 is one element and f of 0, 1 is another element. So each pixel value will be represented with the element f of x, y. So this particular elements generally can be called as image elements or picture elements or pixel or well. So generally most of us will be using the terminology which is called pixel. So as the image is represented in the form of m by n, so the value of m and n should be positive integers. And here we can observe generally image will be represented as f of x, y, where f represents the intensity value. And how many number of intensity levels that can be used means it should be limited and finite. It should be in terms of L is equal to 2 power k. So we cannot take L value as if we like, and we cannot take L value as infinite because due to some considerations like due to processing, due to storage constraints, due to sampling, due to hardware considerations, the value of L cannot be as if we like. It should follow some limited constraints and its size should be like L is equal to 2 power k. So here the value of k is an integer value. Now we will discuss about the actual topic, that is spatial resolution and gray level resolution. So first, what is spatial resolution? So spatial resolution is the measure of smallest discernible detail in an image. So here the term, what is meant by discernible? So discernible means detecting with difficulty. That means small change will be there in the image which is very difficult to detect. So spatial resolution is the measure of smallest change in the detail in an image. And generally the spatial resolution will be measured. That means here we can see DPI. So DPI represents dots per inch. So the spatial resolution can be represented in many ways. It may be dots per unit distance, or it may be pixels per unit distance, or it may be line pairs per unit distance. So generally whatever the value we will be getting, to that the units will be represented as DPI. So DPI stands for dots per inch. That means how many number of pixels are present within that particular distance. So generally this dots per inch concept will be used in the areas like printing and publishing. For example, we have different applications in this printing and publishing area. So for example, we can consider newspapers. So newspaper has a resolution of 75 dpi and magazines have a resolution of 133 dpi and glossy brochures will have a resolution of 175 dpi and book page will have a resolution of 2400 dpi. So if you see all these applications, the value of dpi is increasing. So 75 dpi to 133 dpi to 175 dpi and next 2400 dpi. So we can observe as the value of dpi increases, the resolution of that particular image will be increased. That means that particular image will have high quality. For example, in order to clearly understand about this spatial resolution, we can take the basic application like digital cameras. For example, if we consider 20 megapixel digital camera, the quality obtained from that camera will be very good compared to 2 megapixel digital camera. So as the value of DPI increases, the resolution of the image increases, hence the quality of the image also will be increased. So this is what about spatial resolution. Any image, two-dimensional image will be represented with f of x comma y. So in order to perform this spatial resolution, we have to use the coordinates, spatial coordinates x and y. So we have to keep varying the values x and y, keeping the value of f constant. Then we can observe how the quality of image will be, how should be the values of x and y. Now, next one is gray level resolution. So what is gray level resolution? Gray level resolution is a measure of smallest discernible change in the gray level. So here generally two-dimensional image can be represented as f of x comma y. Here gray level resolution means change in the gray level. So here f is called the gray level or intensity level. So here by making changes in the value of f, we can have gray level resolution. So how could be the number of intensity levels means we know the formula L is equal to 2 power k, where L represents the number of gray levels and the value of k represents any integer value. So here most widely used is of 8-bit and 16-bit, whereas 32-bit is rarely used. Now, so coming to the detailed discussion about spatial resolution. So we have to have a smallest change in the spatial coordinates, that is the value of x and y, which represents the number of rows and columns. So here we can consider this figure in order to clearly understand what is spatial resolution, how the quality of image will be. So here we can consider this is the first image, original image, where its size is of 1024. That means here the size of this image will be 1024 by 1024. So this is the original size of the image. If you change the value of this x and y means, so x and y represents the number of rows and the number of columns. Changing the number of rows and change in the number of columns. Now, so after making this 1024 by 1024 image into 512 by 512. So by deleting some number of rows and some number of columns, this particular image have been downsampled to this 512 by 512 size of the image. And by deleting some more rows and columns of this particular 512 by 512 image, then we are going to get the next downsampled image where its size is of 256 by 256. Similarly, if we observe, as the number of rows and columns in the original image reduces, the size of the image will get reduced. So like this, if we keep on reducing, 1024 by 1024 size of the image have been reduced to finally 32 by 32. So if we observe this image, it is very difficult to observe and the quality of the image have been reduced. So as the value of this m and n reduces, the spatial resolution of the image reduces and the quality of the image will get degraded. So it is not possible to see this image. We can clearly observe in the next slide. Now, so what are the effects of this spatial resolution? So if the spatial resolution reduces, what will be the effects? Reducing the spatial resolution means reducing the value of x and y by reducing or by deleting the number of rows and columns. So if we consider here the same image what we have seen in the previous slide, here we have clearly given. So this is the first image in the previous slide what we have seen. It is having size of 1024 by 1024. So this is 1024 by 1024. So this image, if we reduce the spatial coordinates values x and y, means reducing the number of rows and columns m and n. So we can observe here, in this example, we keep the number of gray levels constant. That means, for example, any two-dimensional image will be represented as f of x comma y. So this x and y are called the spatial coordinates, and the value of f is called gray level. So this can also be called as intensity level. So in this particular example, what we are doing means, we are varying this values of x and y by making the gray level value, that is f, as constant. So this is one particular important point we are considering here during spatial resolution. So in this example, we keep the number of gray levels constant, that is the value of f constant, and we are reducing the number of samples. Here reducing the number of samples means making this m by n value reduced as 512 by 512, next 256 by 256, like that. So here, how we are going to do such type of sampling means, by deleting the appropriate number of rows and number of columns in the original image. So if we consider this 1024 by 1024 as the original image, if we reduce that image, that means if we delete the number of rows and columns present in this original image, then it will be reduced to this size, that is 512 by 512. So here this image is 512 by 512. Again, if you delete the number of rows, this becomes the input now. If we reduce the number of rows and number of columns in this 512 by 512 image, the next image, for the next image, the spatial resolution will get reduced, and this image size will become 256 by 256. Okay, and so from this image 256 by 256, again if you reduce the number of rows and columns, then the size of the image will be, quality of the image will be reduced as the spatial coordinate value reduces. So from 256 by 256, the next image will be reduced to the next value, that is 128 by 128. And in this image particularly, if we observe, in these three images there is no much difference between the quality, and if you observe this image, there is a change in the quality. So in the background, or if you see the petals of this flower, we can observe a small checkerboard like pattern in the borders between flower petals and in the black background. So from this, the image, we can observe degradation of the images observed here. And if you still reduce this 128 by 128 image, then the next formed image is this, and consider the size is of 64 by 64. So compared to this image have been degraded. The quality of this image is less compared to the previous one. And here we can observe one more. If you still reduce the size of 64 by 64 image, and next formed image will be 32 by 32. So totally if you observe this image, the quality is very poor. That means from this we can observe that as the values of this x and y, that is spatial coordinates, reduces, the spatial resolution also reduces, and the quality of the image have been reduced. Now, so that is the best example for spatial resolution. Coming to the next resolution, gray level resolution. So the main difference between spatial resolution and gray level resolution is, as we have considered, image is represented as f of x comma y. In spatial resolution, we are going to vary the spatial coordinates x and y, keeping the gray level constant. Whereas, here in this gray level resolution, we are going to make the values of this x and y, that is the values of spatial coordinates, constant, and we will make the value of this f, that is gray level, as variable. That means we keep reducing the value of f by making x and y values constant. Now, so if you do so, that means if you keep reducing the value of f by making the spatial coordinates x and y constant, what are the effects that we can observe? So if you see, while making this gray level resolution, that is number of intensity levels, the formula L is equal to 2 power k, where k represents an integer and L represents the number of gray levels. Okay. So that means here, when the value of L will be reducing means based on the value of k. So for example, here we can observe, this is the example we can consider in order to clearly understand gray level resolution. So in the first image, let us consider the value of k is equal to 8, that is k is integer here. Okay, and for the next value, k is equal to 7, k is equal to 6, k is equal to 5. Similarly, here k is equal to 4, 3, 2 and 1. So based on this k values, what will be the value of L? What will be the value of L? So L is equal to 2 power k, that is 2 power 8, where its value will be equal to 256. That means here the number of intensity levels will be 256. If we reduce the number of that particular intensity levels, how it will be reduced means based on the value of k. So for example, as k is equal to 7, the value of L will be 2 power 7, where its value is 128. So here the gray level value L have been reduced from 256 to 128. Okay. So next, for the k value is equal to 6, L will be equal to 2 power 6, where its value is 64. So the gray level from 128, it has been reduced to 64. Now, for k is equal to 5, L is equal to 2 power 5, where its value is equal to 32. In this case also, the gray level value is being reduced from 64 to 32. And for k is equal to 4, L is equal to 2 power 4, where its value is 16. So in this case also, from 32, L is being reduced to 16. And for k is equal to 3, L is equal to 2 power 3, its value is 8. So from 16, L is reduced to 8, and L is equal to 2 power 2, the value is 4. L is equal to 2 power 1, 2 power k, 2 power 1, the value is equal to 2. So here 2, L is equal to 2 means only 2 gray levels are possible, which is 0 and 1. So where 0 represents black and 1 represents white. So this is the original image, keeping the values of this x and y constant, and if you keep reducing the value of this f, that is gray level L, we can observe there is a change in the gray levels of an image. So in this gray level resolution, as the value of L reduces, the quality of the image also gets reduced. So if you observe finally the last figure, it consists of only two values, that is 0 and 1. So here keeping x and y constant means the value of x and y will be considered as 452 by 374, that is size of the original image. And the gray levels have been reduced to 256 to 2. So that this is 256 and finally we got 2. Okay. So this is what about spatial resolution and gray level resolution. Now, so here we can observe three figures. So first one is the woman's face, and the second one the cameraman, and the third image consists of crowd. So out of these three images, we have to observe details in an image. So that means what is the amount of content present in an image. For example, if we consider this woman's face, there is a very little detail. And if you consider this cameraman, it consists of medium amount of detail. And if you consider this crowd, as there are more number of people, it is considered as large amount of detail. So how to estimate the amount of detail present in these three images with respect to spatial resolution and gray level resolution means with the help of one graph which is called MK plane. So why it is called MK plane means here you can observe the value of N and here we can observe the value of K. Now, so here we can observe some curves are available in this graph. Those curves are called iso preference curves. So these iso preference curves are drawn between the values of N and K. So here we can observe at the starting values of this N and K, there is no information available. So as the value of N and K increases, the curves will be shifting towards right. See here, the curves first after crowd, next it has been shifted, next the curve related to cameraman, and next it has shifted towards right, and the next we can observe the curve of face. And also if we observe the curves are moving towards like this, towards top. Okay. So in this iso preference curves, we can observe that the curves are shifting towards right and the curves are shifting towards upward as the value of N and K increases. So we can observe what we can observe if the values of curves shift towards right and if the curves are shifting towards top, it means that it is related to the picture quality. So for the larger values of N and K, we can observe the curves are shifting towards right and the curves are shifting towards top, which implies the picture is having better quality. Now, so as the information, as the details in the image is more, it means the curve will become too vertical. For example, we have seen previously three images. In that, the crowd image consists of more amount of detail. So here we can observe this is the crowd curve. So it is becoming more vertical compared to the previous two. Previous two, they are having somewhat curves. But if we observe this, it is more vertical. So the curve become more vertical if the information in that particular image is high. So as the crowd image is having high information, it is more vertical. Next image, medium details, cameraman image is having, and less amount of details are available in the woman face. So this is how the iso preference curves will be drawn based on the details present in the image. Now, so that is what about spatial resolution and gray level resolution. And next topic is here zooming and shrinking of digital images. So in order to clearly understand the concept of zooming and shrinking, we should recall the concepts what we have discussed in the previous sessions, that is sampling and quantization. So while discussing about sampling, we have two types of sampling. One is oversampling and another one is undersampling. So oversampling means increasing the number of samples, and undersampling means removing the number of samples or reducing the number of samples. So here sampling can be of oversampling or undersampling. So oversampling means increasing the number of samples, undersample means reducing the number of samples. So if the number, so here we are going to discuss zooming and shrinking. So here zooming can be related with to this oversampling, whereas shrinking can be related to undersampling. So to clearly understand zooming and shrinking, here I have given different pictures. Like, so this is considered as the original image. If you apply zooming concept on this particular original image, you will be getting zoomed image. Zoomed image means the size of the image will be increased compared to this original image. Now, considering the same original image, and if you apply this shrinking concept on the original image, then the size of the image will be reduced. The size of the image will be reduced and it is called shrinking of image. We can observe the difference. This is the original image. This is the zoomed image. Size of the image have been increased compared to the original image. And this is the shrinking image. The size of this image is reduced compared to this original image. Now we have to discuss in detail about this zooming and shrinking. Now, so we will see here a concept of zooming in detail, because the concept of shrinking is opposite to this. So in zooming, as we are applying oversampling, we are going to add the number of rows and columns. So the size of the image will be increased in horizontal and vertical directions. Whereas in shrinking, in order to reduce the size of the image, we are going to apply undersampling, that is deleting the number of rows and columns, so that the size of the image will be reduced in both horizontal and vertical directions. So coming to zooming of digital images, in order to zoom the original image, two steps need to be followed. The two steps are creation of new pixel location and assignment of gray level to those new locations. So to clearly understand these 2 points, let us consider one original image and we will see if it is zoomed, how it will be, and how about the new pixel values, how to assign new values to the new generated pixels. For example, if we consider any original image whose size is of 500 by 500, and if we want to zoom this original image into another size, for example, we can consider any other integer value. Here in this example, we have considered original image size 500 by 500 and we have zoomed it to 750 by 750. So one of the easiest way to zoom it is, we have to take this 750 by 750 grid and we have to place this grid on 500 by 500 grid. After that, some of the pixels will be matching and some other new pixels will be generated, and to that new pixels we have to assign new intensity values. So how to assign the new intensity values to that particular pixels means, there are two methods. We can follow nearest neighbor interpolation or bilinear interpolation. So in these two cases, we can observe the term called interpolation. Here interpolation means increasing the number of samples. So let us see here, nearest neighbor and bilinear interpolation. Now, so here, if we zoom the image, comparing original image and the zoomed image, so the number of pixels will get increased and we have to allot new intensity values to that particular newly generated pixels. So here pixel replication is applicable when we want to increase the size of the image by particular integer value number of times. Okay. So for instance, if we want to increase the size of the image, we can increase the number of rows and columns. If we increase the number of rows, what happens? If we increase the number of columns, what happens? That means, how about the size of the image? How it will be increased in the horizontal direction? How the size will be increased in the vertical direction? For example, if we increase the number of columns, the size of the image will be increased in the horizontal direction. If we increase the number of rows, that means if any duplicate row is added to the original image, then the size of the image will be increased in the vertical direction. So in this way, by duplicating the number of rows and columns in the original image, the size of the image will be increased in horizontal direction and vertical direction. Like that, we can zoom the original image to any other integer value, number of times. Now, so as I told, we can have the zoomed images by applying two techniques. One is nearest neighbor interpolation, another one is bilinear interpolation. So here are the two examples we got. See, these are the zoomed images. So here, the original size is 128 by 128. For example, this image size is 128 by 128, original size of the image, and it has been zoomed to 1024 by 1024. So here this is the image of 1024 by 1024. Okay, this is the original size of the image. By duplicating the rows and columns, it has been zoomed to, the size of the image have been increased to 1024 by 1024. And similarly, 64 by 64 image have been zoomed to 1024 by 1024. And next one, this is 32 by 32 zoomed to 1024 by 1024. So if we observe, as the size of the image, original size of the image is too less, and if we are zooming it to a too high value, then the quality of the image will get reduced. So this is the image what we have got after zooming by applying the technique nearest neighbor interpolation. And another technique is here bilinear interpolation. Same, like this is 128 by 128 image, it is zoomed to 1024 by 1024. So if we see this second picture, the size of this is 64 by 64 and it is zoomed to 1024 by 1024. That means this is the size of the original image and this is the size after zooming. And here this is 32 by 32 size, original image size. After zooming, the size of the image is increased to 1024 by 1024. Okay. So here these are the three images we can observe after zooming. And the quality of the last image, we can see there is degradation in the quality of the image. So compared to this nearest neighbor interpolation and bilinear interpolation for zooming the images, we can consider this bilinear interpolation is somewhat better compared to this nearest neighbor interpolation, because if you observe this last quality of the image and this last image, compared to these two, this is better. And the same concept we can discuss with the help of example. Like as we have told, in order to perform zooming, we have to duplicate the number of rows and we have to duplicate the number of columns. So in what way we will duplicate the rows and columns? In two procedures like bilinear interpolation and nearest neighbor interpolation. So here consider the example and we have solved this using nearest neighbor interpolation. So here this is the original image. This is the original image whose size is of 3 by 3. It consists of different intensity levels. And if we want to zoom this particular original image to some other values, for example, consider if we want to zoom this 3 by 3 image into 6 by 6 image, we have to duplicate the number of rows and columns in the original image so that we are going to get the zoomed image whose size is of 6 by 6. So for example, if we consider here, there are in this column, if we consider 8 to 10 are the intensity levels. So here we have to duplicate, that means we have to add the rows and columns. So here this is the first column. So this is 8, 2 and 10. So what about this 8, 2 and 10 extra intensity values? Means we have added them in order to make the size of the image increased. So that's why here these three columns, so these three rows I have represented, they are added rows. They are duplicate rows that have been added with same intensity values. And similarly here 5, 18 and 25. So in the original image, here we can see 5, 18 and 25. So this is 5, 18, 25. These are from the original image, and this 5, 18 and 25 are the duplicate intensity values which are being added. And next one is here 12, 19 and 9. So considering this, we can see 12, 19 and 9 are the original intensity values in the image, and this 12, 19 and 9 are the added intensity values. Similarly, here we have considered according to columns. We can also consider according to rows. Okay. Now, so these are the added columns and added rows, that is duplicate rows and duplicate columns that are being added in order to increase the size of the image. So if the column is added and if the row is added, for example, if you duplicate each column, size of the image will be increased in the horizontal direction. If we increase or if we duplicate any row, size of the image will be increased in the vertical direction. So this is how the original image, whose size is 3 by 3, has been zoomed to the image 6 by 6 by applying this nearest neighbor interpolation. And for zooming of digital images, the next technique is bilinear interpolation. So bilinear interpolation is also used to zoom the images. Consider here, this is the original image whose size is of 3 by 4 and it has been zoomed to 3 by 7. So size of the image have been increased from 3 by 4 to 3 by 7. So if you see here, duplicating rows and columns. So here we have 10, 10 and 11. So this is 10, 10 and 11. This is the column which we have taken from the original image. And this is the extra column. Sorry, this is the extra column we have added and new intensity values will be generated. And coming to the original image, the second column is 10, 10, 10. Sorry, 10, 10, 11. And here 10, 10, 11. After this, we can observe here, this is the column which is duplicated. And next column is 11, 11, 11. And this is the original column. And here, based on this, it has been duplicated. And the last column is 11, 11, 11. And this is the particular column. So, this column, this is second column, this is third column, and this is the fourth column, which we have taken as it is from the original image. And these are the columns. These are the columns. These are the columns that are duplicated. So, how we are getting these new intensity values in this duplicate columns means by taking average of these two columns. So, if we consider the first value is 10 and the next value is 10, if you take the average 10 plus 10 by 2, so it is 20 by 2 where the new intensity value will be equal to 10. So, that is what we got 10. Similarly, we can check for the second one. And if we consider the third one, the two values are 11, 11. If we take the average of these two, we will get 22 by 2 whose value is equal to 11 and it is assigned as a new intensity value in this duplicate column. So like this we can also calculate by taking the average value. But if you consider this duplicate column and how to assign intensity value for this means taking average of this 10 and 11. So if you take average value of this 10 and 11, so we will be getting some 21 by 2 whose result is equal to some decimal value. But here the intensity level cannot be the decimal value. It should be any other integer value only. So in such conditions, we can consider either the value 10 or 11 here. So you can consider the value 10 or 11. Only one value in this. Decimal values are not acceptable here. So this is how we will be getting the new intensity values in these added columns. So by applying this bilinear interpolation, the size of the image have been increased from 3 by 4 to 3 by 7. So this is what about spatial resolution, gray level resolution, zooming and shrinking of digital images. So we have taken the content from the textbook Digital Image Processing, which is written by Gonzalez. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.